Welcome back, everyone. Another video, another problem solving question for today. We have 24 days recording this video. 24, I believe. Yeah. Can't believe we've been doing it for this long. My computer, though, she is freaking out right now. She would if she could rent another fan from the house, she would, man. She is struggling with all these software open. When I started recording these videos, I remember it's an Intel 2019 or something. It was pretty good. I mean, it did the job. Now it's struggling to put some videos and some web browsers and stuff out there. But anyways, man, let's go ahead and get these done. Today we have an interesting, very cool question. It's a Microsoft question. How many of you are applying to Microsoft? Well, hopefully me soon, right? Okay, let's go ahead and see what this problem is about. We solved this problem before, but we might have a different solution today. Let's see. The good thing is that I solved this so long ago, like 4 months, and I don't remember really the actual walkthrough. I understand the problem. We'll find out now. Let's go ahead and check. This is the problem, you guys. Valid Sudoku. Microsoft, Uber, Apple, Amazon, Cruise Automation question, and the question statement goes as follows. Determine if a 9x9 Sudoku board is valid. Only the field cells need to be validated according to the following rules. Number 1 says each row must contain the digits from 1 to 9 without repetition. Each column must contain the digits 9 to 9 without repetition. And each of the 9 3x3 subboxes of the grid must contain the digits from 1 to 9 without repetition. Note, a Sudoku board partially filled could be valid, but not necessarily solvable. Only the field cells need to be validated according to the mentioned rules. Cool. We have a visual representation here, and then we have the actual input here as the array, and then we have 5 threes, a bunch of dots, and a bunch of numbers. The output's true. Basically, none of these numbers repeated in the same row or column, okay? As we can see up here. We also see that it's an array of arrays, right? Or a list of lists if you're in Python, or a vector of vector if you are in C++. Anyways, that's pretty much it. The cool thing here is the fact that the dot represents an empty box in the Sudoku board. And then we have another example, same thing with a bunch of numbers and dots representing the dots, the empty spaces. Returning false, it says that number 5 in the top left corner be modified to 8, since the 8 are 2 8s in the left 3x3, it's repeated. So even though we cannot appreciate it here, I assume these, 8 right here, these 2 8s are in the same sub box. And our task here basically is to navigate this matrix and find out where these numbers repeat or if they don't. The cool thing is that it says, let me go ahead and get straight for this. It says here that we only need to check the field cells. So that's going to make it easier, because honestly that's just gonna be a loop iterating over these array of arrays, and every time we see a dot we're probably going to skip that, okay? Because we just need to check if in that particular row or column or box we have duplicated numbers. I want to basically point out here that, technically what we need to check here, they're talking about rows and columns. So let's say, these are our individual rows here. They go all along the board in that manner, okay? Same one here and here. So these are the rows, right? They're going horizontally across the board. And technically, our task is to make sure that if I have a 5 here, that same number doesn't repeat anywhere in that row. Now, we also have columns that go all across the board, and we also have to check vertically if these numbers are repeated. We know that for this board the result is true, so we know, as we can see here just by eye comparison, that at least 5, 6, 8, 4, and 7 are not repeated horizontally or vertically. So that's why the board is true. We see a 7, for instance, down here, and we see a 7 up here, but they're not in the same column nor row. Okay, now there is another thing here that we could check, and it's the fact that it's talking about grids. So 3x3 sub boxes of the grid, or sub boxes, right? So technically that would be this whole sub box in here. So the numbers have to be unique in these sub boxes here. Okay, and talking about the data structure, the first thing we need to identify that this is what we call a matrix. Okay, and the reason it makes it a matrix is the fact that we're dealing with first a 2D array or two-dimensional array. Okay, and that 2D array has rows and columns, and each of these rows and columns have, let's say, a coordinate that we could explore at some point. Okay, but we need to identify these rows and columns, and then we also need to identify these sub boxes in here. And I'm marking these sub boxes as I speak, with the reason that I want to show, right, that these are also index boxes here. So we could say that the coordinates for these boxes inside this array are going to be the following, and they're indexes just like any other index in our array down here. Okay, so these are, let's say, the address of these sub boxes, and obviously I started with a 0 index since we're using Python, but here we need to check, right, that as we iterate over each of these boxes, the condition remains true for not only rows and columns, but also for these sub boxes. And we technically have to build this, okay? Because we could iterate, I would say we could iterate over these rows and columns, very simple, with a nested loop. Yet we need to build this sub box and find its address or its coordinate. So we know, because, for instance, let's go ahead and just take an example. I'm going to delete this and make it less cramped. Let's say we have a 5 here. And when we're checking columns, we see that in that column alone, 5 is not repeated and so forth, right? So even though we have a 5 in the same box in here, horizontally and vertically, it doesn't interfere because they are situated diagonally, right? So that is why if we have a 5 here, we would have to build this sub box, okay? And then check for uniqueness within that sub box, okay? And obviously, if that would be the case, that's false because it repeats within, that's supposed to say false. Sometimes the computer won't let me type, but anyways, if that's the case, that's false, okay? So yeah, I would say for this case, we can keep, and let's talk about a solution now. I was trying to, dissect the problem. We have to find a way to keep the elements we have seen, right? Because we know that we're going to basically skip everything that's empty, but every time we find an element, we want to check if that element belongs to something that we've seen, either a column or a sub box in this case, right? So if that's the case, if that 7 belongs to one, either this row right here, this column, or this box, then we can immediately return false because it didn't meet the 3 conditions accordingly, right? So we're going to need a data structure to keep track of that. The main thing here would be to remember that we're tracking uniqueness, okay? We only have to worry about 9 elements for every time we check, which makes it easy to use something like a set because we would only have to keep track of 9 unique elements from 1 to 9, right? And same thing for the sub boxes, the 3x3. Obviously, building this sub box here would be something we have to think about. Maybe using index division, we can find that as we traverse that array. I want to check the constraints because, okay, the length of the board is going to be equal to 9. So yeah, as we said here earlier, these are 9 boxes here, 3 here, 3 and 3. Okay, that's the length of that box or every array we see, or 2D array. And the length of the every element inside of it's also, equal to 9. So all the way up to 9 from 0 or from 1 to 9. So also the board at that I and j And see, that's a little hint right there. That is telling us we're going to have to explore. Oops, I didn't want to zoom in there. We're going to have to explore I's and J's to find either digits or dots. Okay? But the reason I think this is a little hint that is giving us right here is the fact that we're going to have to iterate over rows and columns. Okay? So cool. Let's see the step by step of the code. I'm going to go ahead and close this right now and proceed with the steps for the code. The first thing we probably need to do here, create a now. Let's go ahead and start building our solution. I'm going to expand this a little bit. We don't need that description anymore. We can reference our graphic down here. So the first step we need to do here is initialize our data structure to store the numbers we've seen for every column, every row, and every 3x3 square. We already said that sets are efficient data structures for this because it will help us keep uniqueness. Another good thing about sets is the fact that we could do checks, right? Existent checks very rapid or very quick. So since we already know we're going to use the sets, another good way to keep track of the numbers is to use a default dictionary. We don't have to import it here since we are in Leap IDE. All these things have been imported for us already, at least the collections model. But we're going to create a default dictionary from the collections model, and we're going to try to access every row and column. And a good thing about that is the fact that if we find an element that is not present in our dictionary, default dictionary would automatically add it to that data structure. So the way we're going to do that is we're going to say columns equal default dictionary, and within we're going to create a set. This is what's going to keep track of the columns, and inside of that dictionary we're going to have a set of unique numbers. Okay, so the way we can imagine this data structure is the following. So it's going to look like a dictionary in Python, and the key is going to basically be an index from 0 to 8. Okay, and this is what's going to represent the index of that column, and that's going to be the key of that dictionary. The value now, it's going to be numbers between 1 and 9. Okay, because this way we're going to know at which index we saw the number. So for instance, let's say here we're going to have 2 as our index, and here we're going to have any number from 1 to 9, so it could be 5, right? So at that column, at column number 2, we're going to see that we have number 5. If as we iterate through the same column we see that there's another 5, we could rapidly using set check back here and see if that number exists within this column. If that's the case, we immediately return false. Now we have to do the same for rows also. So it's basically the same process. We're just going to say rows equal default dictionary and create a set within that dictionary. And it's going to look the same way as up here. And finally, we need to create our subbox or grid. We're going to do that the same way. We're going to say box equal default dictionary creates a set. Okay, so same thing here. Now we have an index for columns, rows, and box, and we're also going to have the numbers we've seen within that particular area of the grid. Okay, so we initialize our data structures. So the next thing we're going to do is iterate through the board and check the index for the row and the index for the column. The way we can accomplish that is through a nested loop, as we mentioned before. So we're going to do that now. Since we only need to iterate over 9 elements, we don't really need to call any data structure here. We don't need to iterate over the direct board, because remember, these elements, all of them are divided by pairs of 3, right? So when we multiply that, we get 9 elements. So if we see here, we have 3 elements, 3 elements, 3 elements, that's 9 for every column. Same thing for every row when we go horizontally. So as we have 9 rows going horizontally here and 9 columns going vertically here, we also have 9 rows and columns in here. So for every case, we're always going to be iterating over 9 elements. So we could say that for R, that it's going to represent our rows in the range of 9, let's go ahead and also check the columns. Remember, we're going to have to check rows and columns. These, and a little thing here that would lead to that is the fact that we're dealing with a 2D array, right? An array of array. So the first iteration is going to determine which one of these arrays in here we're going to be checking. The inner loop is going to be inside of those arrays, particularly checking or looking for those numbers. And that's why we need these two indices or indexes to check for these values. So now we're going to say for columns, same 9 here. Great. So now that we loop through every single cell, row by row, column by column, let's say we're going to start at column and row 0, 0, which would be this one up here. Okay. And then as we move forward, we're going to be iterating one by one with this loop. Now we can start to check if the values in these boxes are either a number or an empty box. And here, to make things easier, we're just going to grab the value of that current cell. And I'm going to add that here as a comment, get the value of the current cell. And we can now create a variable here named current value, which is going to be equal to whatever number we have at that point in our board, at that particular row, at that particular column index. Okay. And here we're simply just grabbing the current value that we are iterating on. With this, then we can start doing our check. Great. So here now we're going to check if the cell is empty. If it is, we're going to skip and move into the next cell because we're looking for numbers. If it's not empty, then perfectly, we'll stop there and check for that number. So if that current value we just created is equal to a dot, and a dot is represented here between quote marks, so it's a string, so we got to make sure we are comparing that to a string, okay? So this is how we're going to do that, equals dot. So if that's the case, then we know that cell is empty and we can simply say continue into the next cell. Basically, an empty cell doesn't violate any of the previous rules we're checking against. So these three right here. So that's the reason why we could move forward in this case. So now at this point, we need to check for duplicates, okay? We're checking rows and columns, but how are we going to build this sub box right here, this grid? How we're going to create that? So the way we're going to calculate that, as we mentioned earlier, and I'm just going to jump into the graphic on the right side here real quick, is the following. We know we have these rows and columns indexes we're iterating over. So we have these rows right here, 0, 1, and 2, and Python zero base index. We have 0, 1, and 2. I'm gonna move these up here, maybe next time. And then 0, 1, and 2 for my columns, okay? And these is the way we're gonna find the coordinates for which the index we're iterating on, okay? So to make that clear, we're gonna say here, basically, R is going to be divided, or floor division, by 3, okay? Because we want to deal with integers, whole numbers, not floating points. So R divided by 3 is going to say, I don't know, at this point, let's say we're in row 1. So right here, these row right here. So that's equal to 1. And now we need to find the column. We're going to do the same thing for the column. So the column is going to be floor division 3 equals, let's say, 2, okay? So if these are their coordinates, index 1 for my row and index 2 for my row, then I'm, checking here. These are my rows. So I'm in 1, so right here, and then 2, so I would be here. This is empty at this point, okay? So our iteration on here would skip that coordinate, okay? But that is how we're going to build that, basically, okay? So I'm going to say here for my box index, and I'm just going to call it like that, that's going to be equal to my index row, and we said floor division because we want to deal with full integers, by 3, and then we also have to do the same thing for column as we mentioned, floor division by 3. And this right here, see how this is a set, okay? We're putting it into parentheses, so the resulting index here would go and form our set here, which is going to be part of our dictionary telling us, remember when I was explaining this is going to be the number we're looking for? Great. So at the box in this, we need obviously both indices to create our box. Great. So guys, I just realized that my camera died in the middle of the recording. So I'm just going to proceed to finish the problem. You're just not going to see my floating head on the screen anymore over here. I guess my camera was a little battery low. So anyways, we're going to continue. So great. So now that we have that index where the 3 by 3 square it's going to belong, we're going to see which square of any one of these that particular row and column index are going to be. Okay, so from there I can start checking for duplicates, and here we're going to check for the duplicates, and the way we're going to do that is basically with a nested condition in Python. And what I mean by that is we're going to say if, and I'm going to open parentheses here, click enter, and within this check statement I'm going to drop all my conditions. The first thing I need to check if it's my current value is within my rows at that particular row. That's the first check. I need to check if that current value we computed up here, it's already part of my rows in here. Okay. The next thing, it's basically the same thing, but for columns. Okay. So I'm going to say my current value in columns at that particular column. Okay. And finally, I need to check my current cell. So I'm going to say if my current value is in my box at that particular box index I calculated up here. Okay, so I'm just going to paste that there. And here we're performing our check in our 3 hash maps. Okay, if that current value is in our rows at that particular row, or that column at that particular column, or that box at that particular index, if is in there, then we can return false because we're for uniqueness. And if it finds it, then it means it's not a unique number. Okay, so great. Till that point, we check for all the duplicates within our data structures. Here I'm missing something though, and I don't want to insert box on my code, but basically I have to do, semicolon, but basically I have to do column there, obviously, to create the indentation. And here I'm going to click tab. Okay, good thing that LeetCode has is that you can format your code here if you need to. So you make sure you're not making any mistakes. Now notice that this for an interview it's not an option. You're not gonna be on an IDE like this, but know that you can have that there. So besides that, I think we check for all duplicates here. Now, if not duplicate was found, we need to add that to our data structure. So in the following check, once we go through the whole thing, if it doesn't find our number in either of these data structures, then we have to add it as a scene number. We have already seen that number. So that's going to be done like this. Columns at that particular column, we're going to add it with .add, and it's that current value. Perfect. So we're going to do the same thing for that particular row, add that current value. Great. Lastly, we need to add the same thing for our box or our subgrid at that particular box index we calculated up there. But add that current value also. Perfect. Great. So if we go through the whole loop, we check and add all the numbers and none of them are duplicate, then we can safely get out of these 4 loops here, nested 4 loops, and return false because basically, and return true because that basically is going to say that our board was valid. Okay, so notice how these 3 conditions or checks I'm doing here exactly match my 3 given conditions here. Okay, and that is basically where the magic happens. Also, if we find the number, we return false. If not, this is something that it's very important too. The fact that we are adding the numbers if the not duplicate was found. And I'm going to add that comment there too to make sure we keep that organized. And finally, down here, we can say that the board is valid. Great. So I think up to this point, we are done with our code. We can submit and see if we get that job at Microsoft. And we did. not is a top one here. 5.87 solutions, 5 milliseconds of runtime. I normally like to go back here and check what these guys are submitting. That's pretty cool there. Okay, sweet. Anyways, this would be enough for us. And yeah, this was day 24. We had some hiccups. We lost the camera in the middle of the recording, but that didn't stop us from finishing our code and completing it. So yeah, thanks so much. If you found value in this video, please subscribe, thumbs up. I really appreciate it, and I'll see you in the next one.